This last section of section 5.3 asks us to consider what the graphs of logarithm functions look like. We've actually seen most of this material before, but I want to just summarize a little bit and then add a little bit that we have left. Remember that if we have an exponential function that goes up like this, the inverse function, which of course is the logarithm function, has the following things. The exponential function has no y values less than 0. The exponential function has no x values less than 0. The exponential function usually goes through 0, 1. The exponential function, the logarithm function, goes through 1, 0. The exponential function gets close to the negative x-axis. The logarithm function gets close to the negative y-axis. And you can see that the exponential function gets more and more parallel to the positive y-axis. So the logarithm function gets more and more parallel to the positive x-axis. You can see that the domain here is all real numbers, because everywhere I draw a vertical line, I hit the graph. The range here is only y values bigger than 0, because when I draw y values up here, I hit the graph, and when I draw y values down here, I do not. The situation is just reversed over here. The domain is missing a whole half plane over here. So the domain is only the positive x values. The range, however, is all values. No matter where I draw y equals constant, I'm going to hit the graph. This graph is always concave up. This graph is always concave down. That's as much as we've actually done with stuff, and that's about 3/4 of what they wanted us to consider. Now, that's one kind of exponential function. The other kinds of exponential functions are the decaying like this. What do their inverse functions look like? Well, this function goes through 0, 1. This function goes through 1, 0. On this one, the positive x-axis is an asymptote. Over here, the positive y-axis is an asymptote. Over here, you can see that this graph is becoming more and more parallel to the positive y-axis. So this one is becoming more and more parallel to the positive x-axis. This graph is always concave up. This graph is always concave up. That's not wrong. But that's why I actually like to draw the graphs before I start worrying about conditions too much. The only thing that they added actually in this last section, outside of the graphs, is the domain of logarithm functions that people have screwed with. And let me give a couple of examples. We'll just draw these and write them down and then draw them again. If I do something like this, I know what the graph of that looks like. Looks like this. And the domain is everything to the right of the y-axis. So every time I draw a vertical line to the right of the y-axis, I hit the graph. The domain here is just everything bigger than 0. Now, if someone screws with this graph, which happens often when we're doing these things. So for example, if I write down something like y equals log about something like x minus 2. Well, we know what plugging x minus 2 into a graph does. It shifts it 2 to the right. So instead of being really, really close to the y-axis, it goes to the right, looks like this, and then goes like that. Now, that didn't change the range at all. Everywhere I draw a horizontal line, I will hit the graph. But it does change the domain. The domain is now just the x values bigger than 2. And we see there's asymptote, instead of being the y-axis, is now the line x equals 2. So those are the two biggie things graphically. There are more complicated logarithm functions that people use, and the domain is very important, so we're just going to talk about that for a minute, and we'll do this the way we have to. So let me write down a log function with a lot more on the inside. Let's see, how about 2x? And we'll go like this. X squared minus 2x minus 3 on the inside. Now, clearly there's a lot going on. We can break this up into little pieces, and I think if this is a high school analysis class where we had 3 days, we'd have a lot of fun doing that. But meanwhile, this is what we're going to do. We know when we normally find domain, we look insides of square roots and we make sure it's positive. Log is no different. If someone asks for the domain of a log function, we have to look on the inside and make sure that's positive. So for the domain, we have to solve the inequality x squared minus 2x minus 3 is positive. I'm going to go over here to do this. I'm going to write down x minus 3, x plus 1 is positive. Now we want to get out of saying this has to be positive and this has to be positive, because you see this could be negative and this could be negative, and so we don't do it that way. You get a lot of cases and it goes nuts. What we do is we do this with a sign chart. We set each factor equal to 0. So I'm going to get x equals 3. I'm going to get x equals minus 1, and those are the numbers that are going to go on my number line. So let's see here. I'm hoping the screen shows up. We'll see. There. Green for my number line. Yay! Right, the x values are going to go here. The function is just going to go here. X minus 1. No, x plus 1. X minus 3. The numbers go on there. So minus 1 goes here. 3 goes here. We know that when we plug in minus 1 into this, we get 0. We know that when we plug in 3 into this, we get 0. And we have to start plugging numbers, one from each interval to do this. So I'm going to say, pick something like x equals minus 2, put it in a little box so we can tell that's a test value. When I put a minus 2 here and a minus 2 here, that's minus times minus, well, that's plus. When I try to plug in, say, something like x equals 0, now notice, by the way, we're not trying to plug x equals 0 into a log function. We're trying to plug x equals 0 into this function, then into the log function. Anyway, so when I plug in 0 here and 0 here, I get plus times minus, that's minus. If I pick a number, say, let's say 10, that's safely away from 3. I put a 10 here, I put a 10 here, I get positive, like that. Now, what do the positive and negative and positive mean again? It means that if I plug in any number less than minus 1 into this, I get a positive answer. If I plug in any number between minus 1 and 3 into this, I get a negative answer. And when I plug in any number bigger than 3 into this, I get a positive answer. And note, what we were looking for was this. So I'm going to put a box for my final answer. Let's do this. How about this? A final answer. What do we need? We need everything to the left of negative 1, and I need everything to the right of 3. And all I'm saying is that we do domains of functions involving logs very, very similar to how we find domains of functions involving square roots.